introduction to the ISA 62443 standards for OT/ICS cybersecurity. Very quick introduction about myself. My name is Mubarik Mustafa, and I am a senior OT cybersecurity consultant with over 30 years of experience in industrial automation and control systems, as well as in OT cybersecurity. And I have a few credentials to go along with my experience, as per on the screen.
Mubarak, we cannot hear you. Mubarak, can you hear me? Um, Mubarak? One second, everyone. I will get it sorted.
All right, how about now?
Yeah, we can hear you.
All right, very
Perfect.
good. Apologies for the technical glitch. All right, thanks for the thumbs up. Mamoon, in the meantime, can you throw the poll, the question we had planned for the audience before I dive into the actual topic? All right, so for everyone, there's a question on the screen. I'd like to understand the background of our attendees today. Which of these domains is the closest to your primary job function or primary area of expertise? Are you from control systems background, OT security, IT security, or other IT functions? Thank you very much for the very quick, fast response. Maybe another 30 seconds or so. Perfect. So I see a lot of folks are close to half of you are from OT security background, which is really good because, of course, that's what the topic is today. Some are from pure control systems background. A little over a quarter are from IT security side, and then maybe about 15% or so are from IT and other functions. So what I'll do is that I'll spend maybe no more than 8 minutes or so just going over the basics of OT cybersecurity and how it differentiates from the IT security. And the idea is that for folks on the call who understand OT security, I'd request them to just bear with me for these 8 minutes because we want everybody to be on the same page. Even if some of this stuff is a repetition for you, just bear with us. So as you can see on the screen, the basics of cybersecurity is fairly straightforward. I still put it up on the screen. What is cybersecurity? Basically, it is the effort to protect computer systems and networks and electronic data against unauthorized access or attack. That's basically, in a nutshell, when we use the word cybersecurity. It is typically associated with IT systems, in the past about email, then business systems and the banks and the ATM machine and the credit card and all that. But obviously things have evolved, and at least half of you know what I'm talking about when I say that OT systems are something different from the traditional IT. For those of you who don't know OT, basically the abbreviation stands for operational technology. And what it means is that all the hardware and software and the networks that are used to monitor and control industrial facility, physical systems. Sometimes people refer to critical infrastructure or anything that is of an industrial or physical nature. Other names for this is industrial control systems, ICS, IACS, something that even ISA started using, but then it declined a little bit. Industrial automation systems, SCADA systems, different names, all refer to different types of or different, I guess, terms used for the OT systems. Typical examples of OT systems you would see out there, and hopefully some of you will recognize the names, the DCS, SIS, the ESD system, SCADA system. I'm sure hopefully all of you have heard the term PLC, but there could be IoT or IIoT or lots of other different types or examples of OT systems. At the end of the day, these are all electronics and computers and networks utilized by industrial facilities to operate safely. That's in a nutshell what the layman definition would be. But moving on, why are we talking about OT security? I think that a slight, I guess, some time needs to be spent on why are we talking about OT security so passionately when we all know that cybersecurity has been in place for decades. We've been talking about cybersecurity since late 90s or early 2000s. Why such a hoopla about OT security? Well, the answer is very simple. It's all about risk, okay? OT cybersecurity is a high risk item for most industrial facilities. Why? Because of the simple equation. When you talk about risk, it's all about vulnerabilities and threat. If you don't have enough vulnerabilities, then your risk would be, even if you have a lot of threats, your risk would be somewhere over here, because less vulnerabilities, even if threats are there, it's not a big deal. I mean, it's still a little bit high, but relatively still not as big of a deal. Similarly, if you have lots and lots of vulnerabilities, but not enough threats, not enough attackers want to attack you, again, it's something that may be tolerable from risk perspective. But if you have lots and lots of vulnerabilities and lots of threats, what that means is that your risk becomes very high. So that's what has happened over the past decade or so, that the risk to the OT security risk or the risk to the OT systems has risen exponentially over the past decade or so. Why so? Because in the past, the industrial control systems looked something like this that you see on the screen. Everything was hard-coded or hardwired. I shouldn't use the word coded, hardwired electrically. So there is no computers, there is no networks. It's a physical wire going from one part to the other. As long as the wire is okay, hey, there is no threat, there is no risk from cyber security perspective. But now modern industrial control systems, they have become very computerized, lots and lots of IT type equipment, lots and lots of networks and servers and workstations, and huge amount of Windows operating system. And that means that, okay, well, now we are a little bit more susceptible to OT threat, a little bit more vulnerable to cyber threats than we were when we didn't have these computer systems, when everything was physically, electrically wired. Now the control systems, for instance, this is an example of an electrical, I would say, power systems architectures. You have power plants which are controlling, where you have computers which are monitoring and controlling the production of electricity. You have substations which are used to distribute or transmit electricity across a country or cities or within the city. And then you have central control rooms which are monitoring the power generation as well as power transmission and distribution. All of this connected through complex networks and computer systems. So the more of these computer systems come into play, the more you are susceptible to attacks from cyber threats. So I'll skip a couple of these slides in the interest of time. What at the end of the day, the message is that more and more control systems over the past decade or so, maybe even before that, have moved towards open systems. You see a lot of commercial off-the-shelf technology, whether it is computer systems looking like IT systems like Dell or HP or Lenovo or what have you, laptops and Windows operating systems and all. Combine that with increased network connectivity and increased connectivity with IT systems. Previously, these control systems weren't as commonly connected with IT systems as they are now. And unfortunately, most of the industrial control systems components were not designed with security in mind. The PLCs and the SCADA systems from 50 years ago or 30 years ago, when they were designed and manufactured, cybersecurity was not a concern. So there weren't too many cybersecurity features or controls built into the technology itself. You would see that a lot of communication protocols in the industrial environment, they're not even encrypted, they're not secure. We are so used to using the web browser, and almost all websites we access now, we know that they're all HTTPS. S means the secure part of it, as opposed to HTTP, which was unencrypted. Well, guess what? In the control systems domain, a lot of the communication protocols, they're still not secure or not encrypted. So cybersecurity, not inherently part of the components themselves. Similarly, when people like folks like me, when we used to design control systems, we never thought of cybersecurity. We just had this thought of making the systems work. Let's design this control system, the DCS, the SCADA system, the PLC, and the fire and gas system to make sure that it functions the way it is supposed to. Who cares about passwords? Who cares about encryption? Who cares about security and closing all the loopholes and all that? Let's just make it happen. Why? Because there were no threats. Nobody was trying to attack the control systems. Even if we have all these vulnerabilities, we were still fairly low in terms of the risk. Similarly, lack of cybersecurity awareness, not just in project folks like me, also with the industrial clients themselves, that even they didn't require cybersecurity because they didn't think, rightly so, up until a few decades ago, that cybersecurity was a concern for the OT systems. So with all these vulnerabilities that we have in the OT environment, that means that we are already at one part of this risk equation, not in a very good shape. What has pushed it up to the top in the high risk domain is that there are lots and lots of threats now for control systems. The bad actors, bad guys, for lack of a better term, they previously used to focus on stealing credit cards and banks, attacking the banks and trying to steal somebody's money through scamming and all those things. They weren't too concerned about attacking industrial control. Why would they? Why would they attack an industrial control system, which is monitoring and controlling a, let's say, oil and gas facility, a refinery, or in an electrical grid? Why would they do that? They're not going to get any money out of it. Well, guess what? In the past decade or so, a lot of these things have changed. You have different types of threats, either coming in from an average hacker, for instance, just for thrill of a challenge that, hey, I turned off the electricity of that particular city, or maybe bragging rights. It could be organized crime. A lot of these criminals, they feel that they can get financial reward from attacking industrial control systems. It could even be industrial espionage, not just the financial gains as well. Some criminals, they may want to sabotage a particular cities or countries' critical infrastructure as well. And then you have these threats from the insiders. Some of these may be malicious, basically, out of any kind of grievances that they may have, or it may be non-malicious, that by mistake they may take certain actions that would result in a compromised situation in the context of cybersecurity. Then we have all these hacktivists, which have either a political agenda or some other kind of, I guess, ideology that pushes them towards either, I guess, making a statement or communicating a particular message. They want to just attack something and make a big deal out of it to communicate their message or make a statement to the general public. Of course, there are terrorists out there which have their own ideological reasons to make or break these systems. And last but not the least, we all know that the geopolitics has changed significantly over the past, I guess, 5-10 years. And lots of state actors or state-sponsored attacks are happening as well. No matter which side of the politics we are, we need to be cognitive of this threat that is coming out of the state-sponsored, I guess, entities. So now that we have a combination of, I'll go back to my beautiful graph of the risk part, that the vulnerabilities were always there for the past 30-40 years, enhanced by increased network connectivity, increased use of commercial off-the-shelf technologies. But now that we have increased threat as well, this is what has resulted in a high-risk situation when it comes to OT cybersecurity. I'll spend maybe a couple of minutes on just differentiating the OT security from IT security. A lot of folks, at least maybe around half of the audience, are from IT background, most likely very well, I guess, good professionals who have spent a lot of time, maybe even securing IT systems. And they may be wondering, what's the big deal? It's the same cybersecurity principles. What's the problem with implementing the same principles on the OT side? Well, to some extent, yes, that's okay. But there are some significant differences when it comes to IT and OT. And a couple of those, when it comes to performance requirements, for instance, on the IT side, your response must be reliable. When you make a transaction in the bank, for example, using either an online channel or physically at the ATM, you want to make sure that if you are depositing a certain amount or taking out some cash, the same amount you receive or deposit. You're not as concerned about, hey, it should take 1.5 seconds. What if it takes 3 seconds or 30 seconds? It's not a big deal. For you, it is important that the response of the IT system is reliable. In case of control systems, the response is time critical. Yes, it needs to be reliable, no question about that, but it needs to happen in the time that is allocated for it. And it could be not necessarily in seconds, sometimes it's in milliseconds. The response has to happen in 100 milliseconds, for instance. In IT system, you have high throughput because you have loads and loads of data going back and forth, whether it is on the internet or on the intranet or the banking system and all. The amount of data is humongous compared with industrial control systems, which have a modest data. I would say even less than modest amount of data compared with the IT systems. So the networks are not as loaded, for instance. In IT, high delay and jitter is tolerated. I gave the example that if you're at the ATM machine and it takes extra 10 seconds to respond, it's just annoying, but what's the big deal? But in this case, in the industrial control systems case, high delay can be a serious concern because you want the computer systems for example, a refinery to respond at a particular time in a particular duration. You cannot afford any kind of delay in terms of how the computers are interacting with the physical systems. In IT, you have less critical emergency interactions, again, because most of the IT systems are dealing with human beings. Usually, there is less criticality when it comes to emergency. But in the ICS case, if it's an emergency, then the response becomes very critical, that the systems must behave the way they have been programmed or else. The IT protocols are fairly, I gave the example of HTTPS and HTTP. and even all the other communication protocols that happen between computers and printers and the applications. They're very, very different from the communication protocols in the ICS environment. When it comes to availability, this is basically probably the biggest difference between IT and OT. In the IT side, you can have scheduled operations. You often get a message from the bank that, hey, the online transactions will be not be available on the weekend, Saturday morning, 1 a.m. to 3 a.m. because they're doing maintenance. Not a big deal. In ICS world, you have continuous operations sometimes for years. The computer systems cannot be shut down even for a second, and it may not be possible to do that for like 3, 4, 5 years. So the computer systems must continue to operate for years in some cases without any kind of interruption. In IT, occasional failures are tolerated. I mean, that's okay, fine. You just reboot the computer, it's not a problem. Rebooting is also tolerated. In ICS environment, no, rebooting may not be acceptable. The outages may not be acceptable. In IT, you can do beta testing in the field. It's possible. You download a trial version of a software and it runs on the computer as a trial. It has a few bugs, but that's okay. It's a trial version. But in the ICS environment, everything has to go through very strict quality assurance, quality control testing before things are put in production environment. In the IT world, modifications are possible with little paperwork as long as you're approved. You have approval to work on a certain, I guess, device or certain computer system or certain network. You can just go ahead and do it. In case of control systems or OT environment, there may be a formal change management process or formal certification may be required after any change is implemented. Another set of differences between IT and OT, operating requirement. IT has typically office applications. We all know that. ICS applications are very specialized. Operating system, you would all see practically Windows or Linux, that's about it. In IT environment, in control systems, you have, yes, Windows is very prevalent when it comes to computers, servers and workstations, but in case of controllers and even some network devices, you have embedded operating systems which are not standardized. In IT, upgrades are straightforward. In OT, they're a big challenge because there are lots and lots of changes need to be coordinated. In IT, you upgrade your computer maybe 3 or max 5 years, even 5 is pushing it. Most systems are upgraded in 3 years. In OT environment, you have 15, 20 years before the systems are upgraded. I'll quickly run through some of these in the interest of time. You've seen the screen. In IT, data confidentiality is the primary, and integrity is the primary, I guess, concern. In ICS environment, it's all about availability. And of course, integrity. You have to have systems must be available. In production environment, they cannot be shut down. In IT, risk impact is loss of data, delay in business operations, and in most cases, financials. But in ICS environment, the impact can be very significant. It can impact physical things. The equipment can get damaged, equipment can blow up, and people can get hurt, they can lose lives. So the impact of the risk, the impact part of the risk is very different in the ICS compared with IT. So I'll leave it at that. It just gives you, I guess, glimpse of, yes, cybersecurity principles are pretty much the same as in IT, but they have to be applied very differently when it comes to OT environment because of the differences that we have just highlighted. So with these differences that we have in mind, let's talk a little bit about the standard themselves. Obviously, when the OT environment is significantly different from IT, that also means that how you implement security on the OT must be different from IT security. And indirectly, it implies that you need to have cybersecurity standards which are more focused for the OT environment than from IT side. On the IT side, the cybersecurity standards have been in place for decades. The OT side, 62443 from ISA/IEC is the de facto, I would say, standard, international standard for cybersecurity of industrial control systems. So that's basically what we will focus on for the rest of the session today. Very quick introduction about 62443. It was developed by ISA, International Society of Automation. Of course, automation being the key over here. And as the ICS and OT systems definition we talked about in the beginning. ISA 99 is the committee, ISA committee, which developed the standards. It was developed in collaboration with IEC, hence you see ISA/IEC always together when it comes to 62443. And most important, this is an OT cybersecurity specific standard. One thing that a lot of folks who are not familiar with 62443 is that it's not one standard, it's a series of standards. So when we say 62443, it is not one standard, it is a series of standards. And that's what we will review today. In a nutshell, it's a comprehensive framework to manage OT cybersecurity. That's what this series of standards is all about. So this slide is basically the overall view of this series of standards. You can see that they're about what, about how many? 9, 10, 11, 12, 13, 14 boxes on the screen right now, divided into 4 sections. So there is a general section. We'll talk about what is in the general section. Then there is a policies and procedures section. There is a system section and then component section. And you will see that each section has its own prefix. So as you can see here, 62443-1- are in the general, the 2- are here, 3- they're in the systems part, and 4- are in the component part. And within these sections, you have 1-1, 1-2, 1-3, 1-4, and then 2-1, 2, 3, 4, and so on and so forth. So all these individual boxes in combined, they refer to the 62443 series of standards. We'll dig a little bit deeper into it in the next few slides, and we'll continue the discussion tomorrow as well. But at a high level, in this series, there are 3 different types of documents. The red ones are marked, are international standards. They're the actual standard that people must follow. And just to pause over here and define the requirement, when we say standard and somebody wants to comply with the standard, then they must follow all the requirements of the standards. It's not an optional thing. If you decide that you will implement 62443, let's say 2-1 in your organization, then you must follow all the requirements of 62443-2-1. You cannot just pick and choose what you like and skip through what you don't like. As opposed to that, a technical report is more of a recommendation that, okay, this is some guidance. If you implement it, it will help you implement things, but it's not something that is a must, that if you do not implement, you're gonna be penalized or you will be non-compliant. And then there's something called technical specification, which is more of an informational in nature. It just helps you understand the concepts better. There is no as such requirements listed in the technical specification. So these 3 colors, red, blue, and green, I have highlighted in the date part on the top. So you can see that 1-1 is a technical specification. 2-2 and 2-3 are technical reports. And the rest, 2-1, 4, 3-2, 3-3, 4-1 and 4-2, these are the actual standards. The dates above each standard refers to when the standard was released. For instance, The 2-1 was originally released in 2009, but 2 years ago in 2024, the new version of 2-1 has been released. So you can see this is the release date on top of each box. It refers to which year this particular standard or TR or TS was released. You probably noticed that some of these boxes don't have a date on above them. Well, the reason is that those are either work in progress or in the pipeline. They have not been officially released by ISA yet, which means 1-2, 1-3, 1-4, 2-5, 3-1. These have not been released yet, but they're in the works, and hopefully ISA will release these soon. So now the message on this slide is that 62443 is not one standard, it's a series of standards, and they are divided into 4 sections: the general section, policies, procedure, or the governance section, the system part, the components part, and then we have the some of the standards and technical reports. Some are released and some will be released in future. All right, so now not only do you have to worry about 62443, you have to worry about 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes, 9 different documents. Each document, which is about, could be 30, 40 pages, 100 pages long. But that's okay. We'll take the complexity out of it slowly. This is another different look, which gives you slightly different view of the same information. I like this view slightly better because it lets me focus on the part that is more important in terms of the standard itself. Same picture, the 1-1 is about terminologies, concepts, and models. We'll talk about that in the next few slides. Then 2-1, 2, 3, 4, they're about establishing the program and the ratings and all. We'll talk about these. These 4 have been released, and especially 2-2 technical report. This was released last year, I think in May. The rest of them have been, some of them have been quite old, I guess. And then the system security components, and then the component security part. Another view of these standards is this one. And this is more from the life cycle perspective, because there are certain things that are related to products themselves. For instance, a PLC or a controller or an HMI software. These are all control systems products. So 4-1 and 4-2, they focus on the products or the components themselves. But in terms of the solution lifecycle, you have the integration part of it. When you, for instance, when you're specifying or designing or implementing or validating the control systems itself, or the operation and maintenance phase, because when the plant is running, you have the operate and the maintain phase, and ultimately the decommission phase. So this picture gives you a slightly, I guess, higher level view of which of these different standards refer to which stage, or they are applicable to which stage. So you can see that the 4-1 and 2 are about the products, and then 1-1 is, it covers the whole, I guess, everyone, because this is about the concepts and the terminologies. When you're designing the cybersecurity program, 2-1 is what is applicable. All the other standards, practically, they apply to the whole of the life cycle for the cybersecurity. 3-3 is slightly odd because it applies to both the product security as well as to the implementation part of it. So same information in the previous 3 slides, slightly differently presented to give you an idea on what applies where. Tomorrow we'll dig a little bit deeper into role-based, or because tomorrow's session is going to focus on practical considerations of 62443. We'll dig deeper into how each of these standards apply to different phases of the life cycle, or different, I guess, from use cases perspective, how the different standards apply. One thing that I when I first started learning about 62443, I kind of got a little bit, thinking that why so many different documents, why so many different standards, why couldn't ISA just make one big document and put everything in there? Well, I mean, each of these has its own purpose. And while it could have been done that everything to put in one document, but then it becomes difficult to apply, difficult to learn, and difficult to implement. I'll spend the next few minutes explaining what is the content of each of these standards, and then tomorrow we'll go deeper into how to apply those to in practical scenarios. One more thing that before we go into the documents themselves, ISA looks at the different roles of the users of the standard, different sets of users who can use the 62443 standards. You have the asset owners, and by asset owners we mean the companies, entities, and the people who own and operate industrial facilities, whether it's an oil and gas facility, refinery, power plant, and all those things. Individuals and organizations who are accountable for one or more automation systems, industrial automation and control systems. They could be operator of industrial automation control systems. They could be operating the equipment under their control. These are the folks who ultimately are the biggest stakeholders, because if a cyber attack occurs or the computer systems are compromised, it's the asset owners who ultimately suffer, who take the brunt of the I guess of the impact. You have product suppliers who manufacture hardware or software for control systems. And then you have service providers, either integration service providers like system integrators, who are doing projects of designing and implementing industrial control systems, or maintenance service providers who are providing services for maintenance of industrial control systems. All these folks are one way or the other. And of course, last but not the least, you have cybersecurity consultants who are providing consultancy regarding the governance and assessment and design and implementation. While all these folks are working on the ICS systems, industrial control systems, or OT systems, or IACS systems, all of these are impacted by the cyber threats. So all of these have to learn different aspects of 62443 to make sure that they perform their work with cybersecurity considerations. So hopefully, after all this discussion over the past 40 minutes or so, each one of you, I would like you to put yourself in one of these roles mentally. It doesn't have to be hard-coded, but at least it'll help you start to correlating to those aspects of 62443 which are closer to your or closest to your current role. So think about it. What's your current role when it comes to what you see on the screen? Are you part of the asset owner organization? Are you a product supplier, a service provider, a consultant? And then going forward, we'll talk about which part of 62443 makes more sense for you. All right. So back to so you'll continue to see this again and again until you get sick of it, or until it gets imprinted in your head and your brain, because at the end of the day, you have to understand all the different aspects of 62443 series. So first, we'll focus on this general part, the top part, the blue part. There's only one of the 4 that has been released, and the Format of each of these slides will be anything that you see in black has been released by ISA. Anything you see in blue is not yet released. It is in works or maybe about to be released. So in the blue section, in the 1- section, only 1-1 is what has been released by ISA. And this document, it basically just introduces the concepts and models used throughout the 62443 series. If you remember, this is a technical specification. This is not a standard itself. It is just an introductory document. If you don't read it, it's not gonna, nobody's gonna come in and give you a non-compliance or audit you against it. But if you don't read and understand this, it will be difficult for you to understand the actual standards and technical requirements. So basically the intended audience is anyone who's wishing to become familiar with the fundamental concepts of 62443. You must read this document. The other three documents are master glossary of terms and abbreviations. I think that a lot of the abbreviations are in each of the individual standards themselves. So maybe ISA at some point in time will consolidate all those into 1-2, but it hasn't happened yet. 1-3 is about system security conformance metrics, a topic that is very important to me personally, because I feel that if you do not have the matrix defined to measure the cybersecurity, then you don't know where you stand. So in my opinion, this is a very important document, but it hasn't been released yet. It just describes a methodology to develop the quantitative metrics derived from the process and technical requirements in the standards. Okay, and then 1-4 will be a detailed description of different use cases of ISE cybersecurity, so that it becomes a little bit easier for the users to understand how these standards can be applied. But again, as you can see, this is more generic. You're not going to have any IS and international standard in the blue. This will be more informational in nature so that people can understand what 62443 is all about, the basics. All right, so we have covered this top part. Now let's move on to the policies and procedures part of it. So in this green box, this is one of the better ones where 4 of the 5 have been released. Okay, 2 are TRs, and these 2 are international standards. 62443-2-1 is probably the most important one, the most basic one, I would say. Anyone who is implementing 62443, in my opinion, 2-1 is the first one you would encounter. And what this is about, it basically defines the security program requirements for ISCS asset owners. So its primary audience is the asset owners themselves who have the industrial control systems. And this standard 62443-2-1 defines the security program requirements for them. It describes what is required to define and implement an effective cybersecurity management system. Okay, and of course, the asset owners are responsible for designing and implementing the program ultimately. They may engage a contractor or service provider, but ultimately the asset owners are responsible. They are accountable for the assets themselves. So this document guides them on how to design and implement the security program. 2-2 is a TR, technical report, and it describes the methodology for evaluating the level of protection provided by an ISCS against the requirements of 62443. So Once you implement all the different aspects of cybersecurity on control systems, you can use the concepts defined in 2-2 to evaluate your level of protection that you have achieved in terms of cybersecurity. Since it's a TR, technical requirement, it is not a must. There is no requirement to comply with 2-2, but it will help you evaluate how good your protection level is. 2-3, well, probably the most difficult one, in my opinion, is about patch management in an IACS environment. Good that half of you at least have something to do with control systems, and I'm sure you know how painful it is to do patch management in the control systems environment because of all the constraints regarding availability and the validation of the patch and the testing of the patch. And if I install the patch, I will have to reboot the computer, but the operation cannot be disrupted. So I cannot install the patch, but I need to have countermeasures implemented because I don't have the patch. Or maybe the OEM, the DCS vendors have not approved the patch yet. So if I install it, it's going to break the software, and then I'm going to be in trouble. So the patch management, in my opinion, in industrial environment is a nightmare scenario. This document 2-3, it provides guidance, again, a technical report. So it provides a guidance. It's not a standard which says thou shall implement this. It provides the guidance on patch management for ICS. Intended audience is, once again, anyone who has responsibility for the design and implementation of patch management program. It could be the asset owners themselves. It could be a service provider, implementation service provider, maintenance service provider. But this document ultimately guides you on how to do patch management. And this itself is I guess, tells you how critical the patch management part, or how difficult it is that ISA had to release a whole separate document just for patch management itself. 62443-2-4, it is a security program. It is a standard that defines the security program requirements for IACS service providers, system integrators who are designing and implementing industrial control systems. They have to comply with 62443-2-4 to make sure that during the implementation phase, or maybe during the maintenance part of it, they don't inadvertently let the system be compromised by a cyber threats. So a lot of asset owners, the end clients, they have started asking their control system integrators to comply with the requirements of 62443-2-4, so that when they provide service to the end client, the service providers systems themselves are secure, their practices and the processes and procedures and the technology in place, they are sufficient to prevent any kind of a threat getting into the asset owners' systems through supply chain. 2-5, that's probably going to be the most important one for the asset owners themselves, because it provides the implementation guidance to the asset owners. Again, it's a guidance document on what is required to operate an effective ISCS cybersecurity program. Okay, of course, intended audience is the asset owners who have responsibility for the operation of the program. Unfortunately, you can see this is in blue, so it hasn't been released yet. So in the 2- series, 2-1, 2-2, 2-3, and 2-4, these are the 4 documents. 2 of these are standards and 2 are technical reports. Moving on to the 3rd section, the system section, which has 3 total documents. 2 of those documents have been released, 62443-3-2, 62443-3-3. Frankly, I used to have a hard time pronouncing these 62443-3-3, 62443-3-2, but you will get used to it. Once you start playing this game yourself, you will get used to it. But what is important is to understand what each of these standards contain. So let's look at that now. As you can see, 3-1 has not been released yet. 3-2 and 3-3. 3-2 is about security risk assessment for system design. So when a control systems integrator, for example, is designing a control system, an IACS, Industrial Automation and Control System, what do they need to do to perform risk assessment when they're designing the system? So it's probably more suitable when the system is being designed, but of course it can apply to existing systems as well. If a control system is running already in a facility, you can if somebody follows the standard, the output will be that you will have a zone and conduit model, and you will have risk assessment done and a target security levels defined for the different components or different sections of industrial control systems. And these documents, the risk assessment report and target security levels, will become part of the cybersecurity requirement specification, CRS, and that's where it applies to asset owners. Is about system security requirements and security levels. One thing I'll tell you that, and let me just kind of pause over here and caution you, warning is a little bit too strict of a word. I don't want to scare you all, but you will have to kind of get used to the different terms that are used in the 62443 standard, because it does take some time to get used to them. The terminologies, the terms and abbreviations, they all have very specific meaning. So when I say system security requirement, it has a meaning. And security level versus security requirements. So security level is different from security requirements. If you don't understand the difference, then it'll become very difficult for you to effectively follow and implement the 62443 standards. And that's why the 1-1 that we looked at in the beginning is very important, because a lot of these concepts are defined in 1-1. So back to 3-3, 62443-3-3 defines the system security requirements and security levels. It describes the requirements for an IACS system based on security level. Well, I mean, it's a repetition of words, pardon me, but that's how words mean. Today is a little bit, I don't want you to get drowned by or get overloaded by all the information that is being presented, but just take the snapshot today about what these boxes are, and tomorrow we'll dive in a little bit deeper into each of these boxes. All right, so that covers the 3- series, which brings us to the last one, the components, the 4- series. Seems like people are happy that we had the last one. I see a lot of thumbs up. Hopefully, it's because they're happy we're getting to the end of it. But the 4- series is relatively easier for most of us, unless you're part of a product company. Unless you design and develop or manufacture industrial control system products, you don't necessarily need to worry about. You need to understand, but you're not going to be using the 4- series a lot. 62443-4-1 and 2 both are released. As you can see, they're in black. But it's about product security development lifecycle requirements. It describes the requirements for product developers, their own security development lifecycle. What will be the requirements for the security development lifecycle for their products? For instance, somebody is designing and manufacturing PLCs. What is the requirement for them to ensure that their products comply with the requirements of cybersecurity? And the 62443-4-2, it is about the components themselves. So the first part is about the life cycle requirements, and the second part is about the components. And in most cases, it describes what features, what security features must be included when companies design and manufacture industrial control system components. It could be embedded devices, host devices, network devices, software applications, hardware, software. All of these are included in the standard, and it defines the requirements for the component product suppliers and manufacturers on what security features to include in their products. So what we have done is that we have gone through, I'll go back over here. Don't worry, I'm not going to go all the way back, just one slide. So what we have done over the past about 45 minutes to an hour is that we have taken this complex, set of boxes and try to simplify it. At least by now, you should have a good understanding of the different components of the 62443 series of standard, that they're divided into 4 sections. Each section represents a numbering system, 1-, 2-, 3-, 4-, and then you have 1-1, 1-2. Which of these are standards? Which one these are the technical requirements? And what is at a very high level, I guess, the topic that is addressed in each of these standards. The key takeaway for you for the past 45 minutes, an hour, is that 62443 is the leading standard for OT cybersecurity. Internationally, this is the only one that is dedicated to OT security, which is a standard. You have a lot of other documents that are more generic in nature. You have the NIST cybersecurity framework or the NIST 882, but those are not standards. Those are just guidelines. Number one, excellent documents, by the way, not to undermine those. If anybody wants to get into OT security, I must recommend you read this 882 R3. It's not in conflict with 62443. It's complementary. It gives you a good basic understanding of industrial control systems, environment, and all those things. But coming back to 62443, this is the only, I would say, the leading international standard that is dedicated for OT cybersecurity. It's a must for asset owners, personnel who are responsible for OT security of the industrial facility, service providers, whether they're OT security service provider or automation service providers. You should know 62443 at different levels. Product suppliers, of course, 4-1, 4-2. Also, IT personnel working in any of these organizations, especially the industrial organizations, because more and more IT and OT cybersecurity is either getting merged or they're fighting with each other. IT security folks, they want to push certain things on the OT side because they have a mandate from the management to protect the environment, and the OT folks, they are resisting because they understand the criticality or the differentiation within the OT part. So if IT personnel understand these standards as well, it'll be much easier to bridge that gap to have a more, consolidated or coordinated effort with the OT folks as opposed to creating conflicts. The series of standards is quite comprehensive. You've seen that. It took us an hour just to go through the boxes. But it also requires significant effort to learn and understand. If it takes us 1 hour to just go through the headings of each standard, then imagine what it'll take to really learn and understand and implement it. Another constraint, of course, I'm sure most of you know that the standards, access to the standards is not free. However, if you become member of ISA, which is not very expensive, I think it's a few $100s or so per year, it gives you free access, view-only access to all these standards on isa.org website. But the key message is that you must, if you want to have anything to do with OT cybersecurity, you must invest in yourself. OT security is not a simple topic. If you want to get into OT security, you must invest in yourself. You get trained, you should get certified, so you can grow your career within the very, I guess, promising industry of OT cybersecurity. There are a lot of folks are asking this question that what official trainings are provided by ISA. ISA has 4 training courses that they offer regarding 62443. They're numbered as IC 32, 33, 34, and 37. There are different versions of it. For example, IC 32E is, I think, online, and then there's an IC 32M, and then there's another IC 32. Some are in person, some are self-paced, and some are instructor, I guess, paced, but they're all on the same topic of the basic course that covers all 62443 standards, and then 3 more courses that address specific topics. The first one regarding assessments, second one regarding design and implementation, and third one regarding operation and maintenance. These are the 4 courses provided by ISA. If you attend these courses and if you take the exam and pass it, if you take the IC32 course and pass, you will become cybersecurity fundamental specialist. If you take IC33 course and pass the exam, you will become risk assessment specialist. IC34 will get you design specialist title, and IC37 gives you maintenance specialist. Don't ask me where 35 and 36 went, because I have no clue. I always wondered, I have OCDs about missing numbers, so I always wonder about it, but it's okay. So these are the 4 courses. If you take the course, attend the courses, official courses, and take the exam and pass it, all 4 of it, then you will get this badge of expert. There is no course for this. There is no exam. If you pass the first 4, you will automatically get the 5th one. This is what the ISA offers. I'll pause over here and let you ask any questions. And Mamuna will present after the Q&A, or maybe even before. She will also present a course that we are offering at ICE, Institute of Cybersecurity Excellence. For preparation, it's a boot camp. It's not an official training course. It's a boot camp that will prepare you for this certification. It is not an official ISA course. You will still have to take this IC32 course to be eligible. Oh, my bad. You will have to still take the IC32 official ISA course to be eligible to take the exam, but passing the exam is not trivial, and it takes quite a bit of effort, especially folks who have not spent 10, 15, 20 years in control systems. It becomes a little bit of a challenge passing the exam. So that's why we have this, we offer this boot camp that helps you prepare and pass the exam to get the certification. So that's it for my lots of talking today. I'll open the forum to any questions you have. Well, all right, so I do see some questions over here. The first few were about sound not being clear. My apologies for that. We had a technical glitch, but seems like that it was resolved after the first few minutes. Question is how to measure threats in organization. Very good question. Obviously, the details will be in one of the, I guess, the preparation work. But at a high level, threats are not inside the. In most cases, threats are not inside the organization. Threats come from the outside. Okay, so this is your entity, and this is the control system inside your entity. Threats are coming from outside. So don't look for threats on the inside in most cases. You may have some insider threats. You may need to have intrusion detection systems in place to see if a threat has already intruded or not. That's a different discussion. My take on threats is that, so if you are responsible for this entity, and I'll call it industrial company, and it is making something critical that is important for the company to keep it running. What difference does it make if there are 2 threats outside, or 5, or 23, or if they're sitting in Asia, or they're sitting in Europe, or in Americas, or they're sitting on the moon, or they're sitting on the Mars? What difference does it make? What you need to do is focus on protecting your facility. How many threats are out there? I don't know, but I can tell you there are a lot of threats out there. So whether they're 35 or 46 or 37 and a half, it doesn't matter. Focus on protecting your infrastructure, your systems. The threats will keep increasing. So instead of focusing on wasting your time on measuring the threats, focus on protecting your systems. All right. What are 62443-1-2, 1-3, 1-4 if they are not colored? I think I answered this question, that these are the 3 documents. They're not standards. These are the 3 documents that ISA may release later, but I think I covered this question in one of the slides. As we do ISO certified 27K1, can we do same for 62443? So yes, I answered that question as well. Is there an official mapping done for 62443 with the NIST CSF? If you, the 2-1 at the end of 2-1, let me clean up this slide. At the end of 62443-2-1, they have mapping with a few standards. NIST is part of that, or a few other, I guess, documents. So yeah, you can look at the 62443-2-1. The rest of the ISA 62443 standards don't necessarily have this mapping. ISA has a separate committee, which I'm part of it, which is doing a lot of these mappings. We even have developed mapping between 27001 and 62443 because a lot of organizations have 27001 implemented at the IT level. So if there is mapping available, then they would automatically know how much they already comply with 62443. That mapping was done by ISA, Global Cybersecurity Alliance, which I'm part of. I think that document is public. If it is, we can make it available to you. Would like to know the difference between 62443 2-1 and 2-5. I think I addressed it, but I'll quickly go back if the rest of the folks don't mind. And if you do mind, please, take care of the person who asked this question. It's not my fault. I just have to answer. But hopefully this slide answers your question. 2-1 is the security program requirements, and 2-5 is implementation guidance. When you look at this document itself, or when you look at any of these documents, they're very complex. And sometimes you have to have subsequent documents to explain how to implement the first document. So 2-5, although not released yet, but once it is released, it will provide guidance on what steps are required to effectively implement the cybersecurity program itself. 2-3 patch management being a tech reporting, is this part of compliance? If no, how the standards body make sure the asset owner has put latest and qualified patches in their install base? So I'll repeat the question again. 2-3, which is right up here on the screen, patch management. If it's a technical report, which it is this part of compliance? No. If no, the question says, if no, how the standards body make sure the asset owner has put latest and qualified patches in the install base? Very interesting question. ISA does not enforce 62443. ISA has developed the standard. ISA does not enforce this standard. You as the asset owner have to decide whether you want to implement 62443 in your organization or not. And you may decide that no, you don't want to implement 62443, and that's perfectly okay with ISA. They don't care. But then you have to figure out how you're going to protect your control systems. But if you do decide to implement, then 2-3 gives you the guidance on the patch management side, because remember I mentioned that it's a very complex topic. So ultimately, the decision on how often to do patching on each system, it rests with the asset owner themselves. There is no one answer that if you do the patching once a month, you're good. If you do it once a week, you're good. There's no one answer. From my point of view, from my personal experience, it depends on how often you have decided to patch your systems. If your decision is, and this is a very important point, so please bear with me. If you have decided that you will do patching once a month, you must do it once a month. And if you have decided that you will do it once in 6 months, you must do it once in 6 months. Both of these companies are okay as far as I'm concerned. If I go in and look at their maturity, I will say, you both are very good. Even though one is patching once a month, the other is patching once every 6 months. They're both good because they have decided based on whatever criteria, which includes the availability and all those constraints we talked about. The problem that I see is that your decision is you will do patching once every month, and then you do patching once every 3 months. So the company which decided to do once every 6 months and they do every 6 months, they are good. The one that decided to do patching once every month and they do patching once every 3 months, which seems to be better than every 6 months, but no, they're in bad shape. In my opinion, they are more at risk compared with the first one. Because when you decided to do it once in 6 months, you must have done some assessment, some risk assessment, including the availability risk and the operational risk and all those things. If you have decided to do 6 monthly, you better do it 6 monthly. There is no one answer for this. All right. What is technically not released under the respect? So I'll skip this because I don't understand the question. How can we get these documents explaining in detail what measures and limitations are to assessed while implementing these standards? The answer is in all of these screens. If you really want to get to the point where if you're just interested in certification, then take the ISA course, take our boot camp and get certified and done. But if you really want to implement it, then you will have to have access to all of the ISA documents. Very easy, get membership of ISA and you will have access to all the documents. And then you can read through them and then you can decide what measures apply to you and what you can and cannot implement. I think I've answered the certification question. When we say system is 62443 compliant, which code standards is compliant, or is it all of them? Good question. If you're talking about system security, maybe we'll address it in more detail tomorrow. But if you're talking about system security, primarily it will be 2-1 and 3-3. System security. primarily these two. We'll test in a little bit more detail tomorrow. Again, it's going to be a 1 hour session, so there's a limit to what we can cover. Are these practical exams or theoretical? The exams are theoretical, so these are multiple choice questions and you have to pick the best answer. There is no practical as such in the exam. What about the 62443 lead implementer certification? I think we talked about that. To be called as, I'll take maybe, there's lots of questions, so I'll just take maybe 3-4 more in the interest of time. Why is it taking them that long to release the standards? I see some of these were released in 2013 and even before that. So why are some other essential documents still not yet released? So why doesn't ISA go ahead and release all these? Because these ISA is the standards on ISA is not like, they're not about 100 engineers sitting in ISA office writing these standards. The standards are developed by volunteers like you and I. People who have experience in control systems and cybersecurity, they volunteer to become part of ISA 99 committee. And by the way, any one of you can volunteer to become part of ISA 99 committee. Based on your background and experience, they will give you certain tasks. So if you and I who have our day job, and then in the evening, we have to go back to our family and the kids and the wife and everybody, and then at the same time, we have to volunteer to write the standard. There's limited time that we can spend on it. So it's a volunteer-based effort, which means that it takes years to write it down. And also, more importantly, the international standards, not the 62443, lots of international standards, they need to be prepared, developed in a way that they apply to a larger set of audience, not just for one particular company. So if I have oil and gas background, I can write a standard that this is how security should be done, but then that may not be suitable for electrical sector or petrochemical or maybe railway. So, and also the standards have to be applicable or implementable for a decent period of time. You're not going to come up with a new standard every year. You probably know that control systems, we talked about the lifetime or life cycle of control systems is 30, 40 years. You're not going to implement a new standard every year. So whatever standard they come up with, it needs to be suitable for, let's say, at least a decade. So that's why it takes a long time for people to give their input, and then it goes out for a review, and then consensus have to be achieved across all the, I guess, the voting members and non-voting members. So it's a fairly complex cycle. But I agree with this part that it does seem that it ultimately takes a very long time. Why are the boundaries between OT cybersecurity team and maintenance team, for example, in dealing with vulnerability patching upgrades? It's more of frankly, a matter of understanding each stakeholder within an industrial entity, whether they're from IT or maintenance or control systems team. You all have your day job. Everyone has the work to do. When another party comes in and tries to force their requirement, even if it's valid, it becomes a little bit of a nag. So this is all about being able to communicate with each other what you're doing, why you're doing, and then have some collaborative environment to make things happen. These boundaries exist everywhere, and there is no one solution to solving this problem. What are the boundaries between, sorry for the repetition. This one is about how do cybersecurity standards differ from one OT area to another? For example, gas, oil, power manufacturing. The basics are the same. Obviously, each industry may have some industry-specific requirements, but at the basic level, like when I talk about 62443, it applies to all the OT industries, oil and gas, petrochemical, electrical, and all these. But then there are industry-specific standards. Like in the US, we have NERC-CIP, pardon my handwriting, NERC-CIP CIP. That is strictly for electrical sector. So you have separate standards for nuclear. There are standards for gas sector in the in gas pipeline sector, for instance. So you may have sector specific standards, but 62443 is very generic. Let me just skip a few. Is GICSP certification can consider all of these covered and okay to go? GICSP is a different certification provided by SANS Institute. They also they provide the cybersecurity certifications, but for not just OT specific. They're very much more broader. 62443 is specific to OT. SANS has GICSP and one more certification which is more focused on OT side, but it doesn't follow any particular standard. GICSP is it helps you build the skills and expertise to implement OT security, but it doesn't give you any certification. I'm sorry, it doesn't follow it. It does give you certification. Pardon me for that. It doesn't follow a standard. So if your company wants to, if you're an asset owner and you want to comply with certain cybersecurity standard to measure yourself how good the implementation is, you will need a standard like 62443. SANS doesn't have a standard. It just provides the GICSP certification to prepare you for OT security. One last question, I would say. I'll take the last one that was posted here. Any auditor certification available specific to ISA 62443? Like, not yet. ISA is coming up with some audit. ISA doesn't even at this time audit the implementation, let alone the auditors themselves. So if your company if you're the asset owner and you want to implement 62443, ISA doesn't even come in and validate if you have implemented it correctly or not. At this time, ISA doesn't do that. And from what I know, as far as I know, there is no auditor certification. ISA does have a few certification programs. Maybe we can talk about it tomorrow. So I'll leave it at that. It's been an hour and a half, and I'm sure everybody is tired of listening to my talk, my blabbing. So we'll pause over here until tomorrow. Back to you, Maimuna, for closing thoughts, and if you want to tell everyone about our bootcamp, please. Thank you.
Thank you, Mubarak, for such an informative session. I really enjoyed it, and I hope every one of our participants enjoy it as much as I do. Before we close for today, I want to make an announcement that based on your queries and based on your recommendation, we are hosting a 16 hours intensive course bootcamp on 62443. It will be in April 11, 18th, and 24. I guess, let me confirm this, 25. It would be a paid course, since we have to gather lots of our resources from outside the company, like Mubarak. He was very kind enough to join us for this. So we would be hosting it in a paid way, but it would be an intensive 16 hours course in which you would get all the resources, the certificate, the badge, and help from our trainers as well during the 16 hours course. But we will not share the price now. It is a surprise for you. We will be sharing it tomorrow. But the thing is that you have to be here tomorrow to avail that exclusive offer that would be available for only 30 minutes. Afterward, the price would be full. You have to pay the full amount to enroll in the bootcamp. So I hope to see you tomorrow to avail that exclusive offer, and see you tomorrow. Thank you, everyone.